All right, so I've got a drawing here for number one. I'm not going to go through all of this with you, but I wanted to go through just to make sure that we were good on this. Pardon me. I've got my VI, my VF, my HI for part B here, and you'll notice that this says how fast is the coaster traveling at the bottom of the first hill. So that's here, which means that the HF is 0. So remember, what we're going to do is every time we have a VI, I'm going to calculate a KEI. So 1/2 mv squared. Well, this is 0, so it's going to be 0. We don't know KEF. HI, we're going to do PEI, which is mghi, or 1300 times 9.8 times 60. So I'm getting 764,400 joules, and the PEF is going to be 0. So when I set up my block equation, I've got that the sum of all the initial energies plus any work done is equal to the sum of all the final energies. What energy do I have to start with? Well, up here I only have potential. This is frictionless. There is no friction, so work is 0. And the energy final is going to be kinetic. So I sum all this out, and I should get that KEF comes out to be 764,400. And then the last step is to go to KE equals 1/2 mv squared again. And then I've got 764,400 equals 1/2 times 1300 v squared. So I think if I divide by my 1/2 and then divide by my 1300, I've got v squared equal to, v squared equal to 1176. And then if I square root both sides, I've got that a v is 35.3 meters per second. So that's just to make sure you're good on that. And then if you went on to part C, you should have got 22.1 meters per second. And very briefly here, I just want to make sure to go over part D, because we did this in the lab, but other than that, we haven't done much with this, which is what happens when there is friction. So this is saying, let's add friction to the problem. With friction, the roller coaster only makes it up to 30 meters here. So it ends right there. Okay. So this time when I do my knowns and unknowns, I'm still starting at 60 meters, but I'm ending at 30 meters. I started from rest, but if I run out of speed and don't go up any higher, that means I'm also ending at rest. And my goal is to find work. So when I do this, I get a PEI here is mgh. Should be, well, it should be the same as up here, 764,400. This one is going to be m times 9.8 times 30. This one's coming out to be 382,200. And these are obviously going to be 0. And when I plug into the equation this time, what kind of energy do I have at the beginning up here? Oops. Where did my go? What kind of energy do I have up here? I still have only potential energy here at the beginning. And then I do have work this time, but what energy do I have here? I'm used to saying that that's kinetic energy. But if I've run out of speed on the way up, this again is potential energy. So then I have PEI, which is 764,400, plus work equals 382,200. And how do I solve this? I've got to subtract this time. So I get a work equals negative 381,200. 800 joules. Does it make sense that work is negative? Yes, it does make sense that work is negative because I'm losing energy, right? Okay. On the back here, I'm going to just give you the answers so that you can check. This follows very similarly to what we did on the front. But let's see here. So let me real quick solve this out so that you can check your answers. So 1/2 times 2 times. So I'm getting that this would usually makes it 1.27 meters up. And then how much work is done by friction there? I'm getting negative 3.44 joules. So hopefully you got that. And then finally, number 3, I put number 3 on there because you can solve that using our equation. The black equation should still work for this. But whenever, you can also use the green equation whenever you're on level ground. So if you wanted to in this one, you could say how much work. I can say it's delta KE. So if I calculated, you would be doing this, solving this out. But if I calculated the kinetic energy, ooh, that's a lot. I should get that work ends up being here negative 10,425,000 joules. And then I can do work equals force times distance here, and I should get a force of negative 16,875 joules. You should be, we're going to get more practice on this tomorrow. But again, I'd like to just see how far you got. So turn this in if you haven't yet. You should at this point have turned in the Marble Lab. And then I want to see where you got on this. We'll work some more on the review tomorrow. So if you had questions today, I'll be here tomorrow to answer any remaining questions that you have. All right, enjoy the rest of your day. I will see you tomorrow.